Hi and Assalamualaikum everyone. Today we would like to present about experiment 2, which is basic measurement of length, volume and density. Before we start, let's introduce our teammates. First is Farid Kamil, Ayuni Hasanah, Irfan Nazmi, Amira Ashkin, Izzy Natasha and Nurul Rahmah. The objective for this experiment is to determine the volume and density of ball bearing and to determine the volume and density of glass block. So, here is the apparatus for this experiment. First, we need to have vernier caliper, micrometer screw gauge, glass block, ball bearing and wetting scale. Procedure A. Micrometer screw gauge. First, zero error were determined. Next is the diameter of ball bearing were measured. Step 2 was repeated about 3 times at different positions and the data was recorded. The actual diameter reading were calculated.
Procedure B. Vernier caliper. First, the whole number of small divisions on the fixed part of the caliper that are left of the zero mark on the vernier were counted. Second, the first mark on the vernier that lined up with one of the marks on fixed part of the caliper were found. Third, the zero error of the vernier caliper was determined. The length, width, and thickness of the glass block was measured by using the vernier caliper. Step 2 was repeated at least 3 times at different positions of the glass block. All of our data was recorded in a suitable table. The actual measurement was calculated by taking into consideration the zero error obtained earlier. The density of the glass block was calculated.
For result, to measure the diameter of the ball bearing using a micrometer screw gauge and to determine its volume. Formula of volume is equal to 4/3 multiplied by pi and r cube. Observed reading for diameter of the ball bearing is 19.03 mm and for radius we got 9.52 mm. Micrometer screw gauge has zero error, which is equal to minus 0.01. Because of that, our true reading for diameter of the ball bearing is 19.03 mm and for radius of ball bearing is 9.51 mm. Next, to measure the length, width and height of glass block using a vernier clipper and to determine its volume. Formula of volume of glass block is equal to length multiplied by width and multiplied by height. Our observed reading, we got length is equal to 9.81 cm and for width 1.86 cm and for height 6.03 cm. Vernier clipper don't have zero error, which is equal to 0. Because of that, our true reading for length is equal to 9.81 cm and for width 1.86 cm and for height 6.03 cm.
As for the analysis, we have to calculate the volume and the uncertainties of the ball bearing and the glass block. For the ball bearing, we have to use the formula of volume, which is 4/3 pi r power of 3. So volume 4/3 pi multiplied with 9.52 times 10 power of -3 meter power of 3. So your volume will be 3.614 times 10 power of -6 meter cube. To find the uncertainties, we have to use delta V equals to 3 delta R over R multiplied with volume. So 3 multiplied with 1 times 10 power of -5 meters over 9.52 times 10 power of -3 meters multiplied with 3.614 times 10 power of 6 meter cube. So, your uncertainties for the ball bearing will be 1.138 times 10 power of 8 meter cube. So, to find the volume of glass block, we have to use the formula, which is length multiplied with width multiplied with height. and our uncertainties for the glass block will be delta V equals to 4.43 times 10 power of negative 7.
Number 1, calculate the density and the uncertainties of the ball bearing and the glass block. For both objects, we use the density formula, which is mass over volume, and then we use the answer to search for the uncertainties for ball bearing and the glass block. To search for the uncertainties, we have to use the density formula as well. So uncertainty rho equals to uncertainty m over m plus uncertainty volume over volume times with the real density. Same goes with the glass block. We have to use the density formula to find the uncertainties.
In this experiment, length, volume and density can be used to measure the quantities accurately. Using the micrometer screw gauge, volume of ball bearing will result 3.614 times 10 to the power of negative 6 m3, and the uncertainty of V is 1.138 times 10 to the power of negative 8. The density of ball bearing will calculate 7083.56 kg meter cube, and the uncertainty of P is 25.07 kg per m3. Vernier caliper was used to measure the glass block. From the calculation based on the data, volume will result 1.1 times 10 to the power of negative 4 m3, and the uncertainty of V is 4.4 times 10 to the power of negative 4 m3. Besides, the density of glass block is 2480 kg per m3, and the uncertainty of P is 10.08 kg per m3. Next, there is some error during the measurement, such as misreading a scale or incorrectly recording data. Thus, repeat the measurement and read the scale correctly to get the accurate reading.
The main objective on this experiment is to determine the volume and density of ball bearing. The volume of ball bearing will result V equals 3.61 multiply 10 negative power of 6 plus 1.138 multiply 10 negative power of 8 m power 3, and the density is P equals 7083.56 plus 25.07 kg per m power 3. Volume and density of glass block is determined from the calculation. Volume of glass block is V equal 1.1 multiply negative power of 4 plus 4.43 multiply 10 negative power of 7 m power 3, and the density resulted P equals 2480 plus 10.08 kg per m power 3.